E6B aka the Whizzwheel. Today we'll be discussing all sorts of questions that can be asked from the Whizzwheel in the PPL exam of SACAA, and usually these questions are asked in navigation and flight planning. So what I have done is basically gathered all sorts of questions into one particular video, so it's very convenient for you. And maybe you can go and give both the exams on the same day because both are basically maths and maybe a little bit of geography. Sorry, geometrics, a little bit of theory in navigation, that's it. So yeah, it's not that difficult. We can jump right into the video and you can see we have total 6 types of questions. Now the first one and the second one are basically similar. So starting up with the first question, we clearly have track, wind speed, the wind direction and the task given to us, and what we have to do is find the heading and the ground speed. So I do have prepared some sample questions over here, and maybe it's better if you guys sit with a pen, paper and your E6B. That's great. Just do along with me, keep repeating, and I hope you understand what I'm saying. The sample question says us the track to be 220 degrees, the wind speed and the wind direction is 20 knots and 270 degrees, and the true airspeed is 110 knots. So the first thing that we are going to do is bring the wind direction under the true index, that is 270 degree, which is west. So under the true index I have put west, and now what I'll do is bring the center dot to 100. So these are the first 2 steps that you need to follow. So once this is done, now what we'll do is we'll mark the wind speed up. What do I mean by this is 10 units and then another 10 units, which is a 20 knots. So you make a tiny little mark on 120. So after doing that, what we have to do is now we'll rotate the wheel until we get the true track. The track that is given to us is basically true. So we'll bring the track under the true index, which is 220 degrees. This was the another step. Now moving forward, now what we'll do is bring the tiny pen mark until we get to the task. You can see the pen mark is slightly above 110 knots, and 110 knots is our true airspeed. So we'll slide it down just slightly so that the pen mark is aligned with the 110 arc. So we have brought the pen mark to the 110 arc. Now we can just go ahead with our solution. It's right in front of us. The ground speed is the center dot, which is somewhere 92, 94, 96 and maybe a little above. So yeah, it can be a 97 knot. For our heading, we can clearly see that the pen mark is on the right side of the center line, which is the true index. So we'll just have to count a 2, a 4, a 6 and a 8. So that means a 8 degrees towards right. So we'll just add it to 220 degrees, which is 228 degrees. So our heading is to be 228 degrees. These steps are a bit complex, but it's not that difficult. You can just write down these steps as we are going ahead with the questions. It will be way convenient for you guys. And if in the same question we had the pen mark on the left side, so we'll be subtracting the number, as conventionally the bearing decreases when we go left, right? So if it's on the left, you'll subtract the number, and if it's on the right, we add the number, as we did with the 8 degrees. We added the 8 degrees to the 220 degrees. Simple. So the next question is similar to this one, and moving ahead with the next question. And the first thing, you'll clearly see that instead of track, now we have been given with a heading. So what we have to find is a track and a ground speed. So the first 2 steps are completely similar. You have to bring the wind direction under the true index and the center dot to 100. So now what we did in the previous question, that we marked the wind speed up, but in this question the catch is that we'll be marking the wind speed down. In this case our wind speed is 15 knots, so we'll go 15 units down from the center dot, which is 100. So when we go 15 units down, so it's a 90, which is a 10 units, and the another 5 units will make it a 85. So yeah, so the marking will be sitting right about there at 85. Perfect. What we'll do, the next thing is rotate the dial until we get the heading under the true index, and our heading is around 280 degrees. So we'll just rotate it so that 280 degree aligns with the arrow of the true index. Now as we bring the heading, which is a 280 degrees, under the true index arrow, we clearly see that the pen mark moves towards the right. Now unlike the previous question in which we were putting the pen mark on the task by sliding the scale up and down, in this question we have to put the center dot on the true airspeed. True airspeed given to us is 130 degrees. So we'll slide the center dot to 130 degrees. Now, as we bring the center dot from 100 slowly to 130, we have our answer in front of us. But unlike the previous question in which we were reading the ground speed under the center dot, in this one, we have our ground speed under the pen mark. So we'll have to increase from the 130 arc. So every unit is an increment by 2 knots. So it's a 132 and a 134 knots increment. And for the track, it's the same as the previous question, as the pen mark is on the right side of the center line. So we'll have to count, and every unit is a 2 degrees increase. So it's a 280 degrees. So it's 282, 284 and a 286. So it's roughly 286. Our track is 286 degrees. So moving on with the third question, we have to find the wind speed and the wind direction. And we have been given with the track, heading, task, ground speed, basically everything. The first two things that we have to do in this question is put the heading under the true index, which is 110 degrees, and the task, which is 110 knots, under the center dot. So heading, true index, and the center dot should be on true airspeed. Before moving on to the third step, we need to be clear with one concept. We know that heading is where the nose of the aircraft is pointing towards, and the track is the path that the aircraft is meant to be following, right? And as pilots, our tendency is to make the correction by flying into the wind, putting the nose into the wind to counteract the drift. In the given question, the heading is 110 degrees and the track is 120 degrees. Clearly, the heading is on the left side of the track, which means our drift is to the right. The wind is trying to push us to the right. That is why we are putting the nose to the left into the wind. So basically, flying a track of 120 degrees like this, we are putting the nose into the wind and flying it like this. If we did not make the correction, we'll be ending up following a track of 130 degrees. So basically, long story short, our heading is on the left side of the track, which means the wind is trying to push us to the right by 10 degrees. So our drift is to the right side by 10 degrees. So what we'll do is mark the 10 degrees line from the true index with a highlighter, as I have done on the Whizzwheel. We'll also do the same for the ground speed. The given ground speed to us is 120 knots. So what we'll do, the arc for 120 knots, will mark it with a highlighter as well. Now you can clearly see both the lines of the highlighters are intersecting at a particular point. Now I would prefer a gel pen. With the gel pen, what you have to do is give a very fine mark at the particular intersection between the ground speed highlighted line and the drift highlighted line. Now the intersection has been marked with a very fine mark of a gel pen. What we'll do is rotate the entire intersection, rotate the entire visual unit so that the intersection is exactly below the center dot. You have to rotate it in a clockwise direction. After we bring the intersection below the center dot, the wind speed is right in front of us. The difference between the center dot and the pen mark is basically our wind speed. So it's a 10 units, 20 units, and this small gap represents 2 units. So in total 12 knots. Our wind speed is 12 knots. For the wind direction, it is just below the true index, which is 000 degrees or 360 degrees, whatever you want to call it. It's basically the north. Moving on with the fourth type of question. In this question, we have been given with our runway orientation, that is our runway heading, and the wind speed, the wind direction, and it's telling us to find the strength of the headwind and the crosswind. So the first thing that we need to do is bring the runway heading, which in this case is 080 degrees, under the true index. Once that is done, we need to find the difference between the runway heading and the wind direction. The incoming wind is from 120 degrees, so the difference between the runway heading and the wind direction is 40 degrees, right? Once this is done, what you have to do is, basically everything was being done on this side of E6B. You just have to flip it around and you'll see a small box underneath, right? So you have to locate the difference, which is 40 degrees, on the upper bar. Once that is done, you'll have to locate the wind speed given to us, which is 30 knots, on the y-axis on the left side. After locating both of these, you have to intersect the values. And once you intersect the values, the upper left value represents the headwind and the lower right value represents the strength of the crosswind. Simple. Now moving on with the fifth type of question is it's basically now finding the tailwind and the crosswind. There's a little catch in this one. Let's move ahead with the question. So it gives us the runway heading of 060 degrees and the wind direction of 180 degrees, wind speed of 10 knots. We have to repeat everything. It's the same. So we'll bring the runway heading under the true index 060 degrees, and the wind is coming from 180 degrees. You see? But in this case, now if you find the difference between the runway heading and the wind direction, you'll see that it's more than 90 degrees. And on the given table, we don't have any value above 90. So the difference between the runway heading and the wind speed is 120, and we clearly see that there is no 120 on the given upper values of the table. So what we'll do in this case, and this is the catch with this type of question, is that we need to subtract 90 from the difference, and in this case our difference is 120. So the value that we'll get is 30 degrees, and we do have 30 degrees on the upper given values. Once you locate 30 degrees on the upper value, you will have to locate the wind speed, which is 10 knots on the left y-axis, right? Once you both of these have been located, you'll have to intersect both of these values, and our answer is 9 by 5, right? But in this case, 9 is not our headwind and 5 is not our crosswind. Rather, 9 becomes the crosswind and 5 becomes the tailwind. So basically, the headwind becomes the crosswind and the crosswind becomes the tailwind. Fourth and the fifth questions were basically similar, but the exception with the fifth question was that when the difference between the runway heading and the wind direction exceeds 90, we'll subtract 90 from the given value. Whatever the value is, we'll locate it on the upper values. We'll locate the wind speed on the y-axis on the left side. We'll intersect the values, and the answer would not be headwind and crosswind. Rather, it will be crosswind and tailwind. So yeah, that's it. So let's move on with the sixth question and the last question of the video. So the sixth question tells us that we have a rectified airspeed of 86 knots, an altitude of 8500, and an outside air temperature of 5 degrees centigrade. For this question, you'll have to turn the Whizzwheel around again, and we'll be doing everything on this particular section of the Whizzwheel. What we have to do is the 0 on the screen is basically our reference or the datum. Now from this particular reference, we have to go positive 5 degrees, right? And the positive is on the left side. So don't confuse it with the normal conventions. As you can see, the positive 50 is written on the left side, so we'll have to go towards the left by 1 unit. Every single unit is 5 degrees, so we'll just go by 1 unit because our outside air temperature is positive 5 degrees. So that's a positive 5 degree, and the altitude given to us is 8500. Now what we have to do is align the 5 degrees with 8500. So this is our 5, 6000 feet, 7000 feet, 8000 feet, and somewhere in the between that will be 8500 feet. In this question, it really demands you to be very eye focused and very accurate. It's not that difficult, and it's just demands you to be very focused with the values and the markings. So once you have aligned the temperature with the altitude, which is 5 degrees with the 8500, what you have to do is come up over here, and the lower section basically represents the rectified airspeed and the upper section represents the true airspeed. So the given rectified airspeed to us is 86 knots. What we have to do is locate it on the lower section, which is 81, 82, 83, 84, 85, and this one will be our 86 knots. Perfect. And we clearly see that the 86 knots is aligning right about with this particular line over here. So what we have to do is count towards this line from the upper section, which is 95, 96, 97, 98, and roughly 99. So our solution would be the TAS is 99 knots. So yeah, these were the few questions that you can expect in the PPL exams of SACAA, and it's basically from both navigations and flight planning. I compiled all the questions into one particular video. Just be sure with your procedures with this particular thingy over here. I don't know why do some people call it the Whizzwheel, but yeah, you guys can clear your papers in the first attempt too, and best of luck for your exams.